We're going to explain how to fix the could not convert string to float error that often pops up when you're trying to calculate a line of best fit in Python. This error usually means your code is trying to perform a mathematical operation, like calculating an average or slope, on data that's stored as text instead of numbers. Let's dive into the common causes and solutions. 1. Identifying the culprit. The error message usually pinpoints the exact line causing the trouble. Carefully examine that line and the data it's using. You'll often find that a variable meant to hold a numerical value contains strings. For example, if you are reading data from a file, a comma might be present in the data, unexpectedly resulting in string data. This often happens when you're reading data from a file, like a CSV or text file, where numbers are mixed with other characters, or when user input isn't properly validated. 2. Data cleaning and pre-processing. Before you do any calculations, make sure your data is in the correct format. The most common issue is having strings where numbers are expected. The solution is to convert those strings to numerical types, float or int, using Python's built-in functions. Here's how you can tackle this, illustrating the method with a list called data points. 3. Using float for conversion. The simplest solution is to use a loop and the float function to convert each element in your list. For instance, cleaned data equals float x for x in data points if x replace is digit. This line iterates over your list and converts each element to float, checking if it's a valid number first using is digit. The replace bunt1 part is helpful for handling numbers containing decimal points. This ensures that only valid numerical strings will be converted, and it gracefully skips over non-numeric values without crashing your program. You can adapt this to your specific data structure, like a NumPy array or Pandas data frame. 4. Handling non-numeric data. Often, your dataset might contain non-numeric values like headers, empty cells, or strings representing missing data. These need to be handled separately to prevent errors. In such cases, you can add error handling using a try-except block inside your loop, gracefully skipping over these invalid entries. 5. Input validation. If the data comes from user input, validate it before attempting conversion. You could use a while loop to repeatedly ask for input until the user provides a valid number. You can prompt the user for valid input until a float is entered. This can prevent errors before they even occur. 6. Inspecting your data. Before starting your calculations, print out or visually inspect your data to ensure it's in the expected format. This often helps you spot the problem before it causes an error. 7. Using libraries effectively. Libraries like Pandas are excellent tools for handling data effectively. If you're working with larger data sets, Pandas provides functions that simplify data cleaning and conversion, making your code cleaner and more robust. Its to-numeric function will try to convert columns to numeric types while managing potential errors in a controlled way. By following these steps, carefully inspecting your data, and using appropriate error handling and data conversion techniques, you can efficiently resolve could not convert string to float errors and successfully compute your line of best fit. Remember to adapt the solutions to fit the specific structure and characteristics of your dataset and how you're reading.